in this next example, we have a travel agency that claims that the average daily cost of meals and lodging for vacationing in Texas is less than the average daily cost in Virginia. Certainly, Texas and Virginia are independent of each other. We've got 2 random surveys that were taken, so these are random, meets that condition. We know the population standard deviation for both. Sigma is known. And they tell us that they are normally distributed, even though the quantities are less than 30. So we can use that. So our conditions are met. So we can create our null and alternate hypothesis. They're saying that the claim is that the travel agency says the average daily cost of meals and lodging for Texas is less than that of Virginia. So mu1 is less than mu2. Therefore, the null hypothesis has to be mu1 is greater than or equal to mu2. This one is the claim. From there, we know that we can continue with a z-test. Therefore, we have a left-sided test, and we can find that z-naught score when this is alpha of equal to 0.01. So using inverse norm, we can say that that is negative 2.3263. We're going to find the standard error by taking the square root of the standard deviation, population standard deviation for Texas, quantity squared divided by Texas's n, which is 25, plus the standard population standard deviation for Virginia, which is 25 squared, over Virginia's sample size 20. Putting those in the calculator, you get 6.8738635342. From there, we can find our actual z-score for our values. We want to use the 245 from Texas minus the 251 from Virginia minus the difference between the population means, which we always assume to be 0, divided by our standard error, 6.8738635342, which gives us negative 0.8728715,609. And that z-score is not in the rejection region. Therefore, we fail to reject. The null hypothesis. There is not enough evidence to say that the average daily costs of meals and lodging in Texas is less than in Virginia. Now we can also do these tests on our calculator. So on the calculator, in order to do this test, we need to hit the Stat button, then move over to Tests. And the test we're going to perform for this one is called a two proportion, whoops, not two proportion. Don't write proportion. It's not a proportion, these are means. It is a two sample z-test. That's the one you pick out from the list. You're going to enter the stats for this because that's what you know. And your stats are going to be that sigma 1 is 20, x sub 1 is 245, and n sub 1 is 25, where sigma 2 is 25, x sub 2 is 251, and n sub 2 equals 20. Since this is a left-tailed test, you're going to pick that mu1 is less than mu2 from the list, and you're going to get exactly the same results as we show up above here in the red, the blue, and the green. Okay, but it will also give you a p-value that will confirm this. And the p-value in this case is 0.191366, which is definitely not within 0.01. It's greater than 0.01, so you would reject it. Now we could have taken this z-score and put it into normal CDF and found the p-value ourselves, and we would have gotten this exact same p-value. You are going to do page 444, 1 through 33, every other odd.